Hello, ladies and gentlemen. Welcome to Math 10C, Chapter 4.1, Review of Polynomials, Multiplying Polynomials. Now, today we're going to get through several important things. First, we're going to model the multiplication of two given binomials concretely or pictorially and record the process symbolically. We're going to relate the multiplication of two binomial expressions to an area model, and we're going to explain using examples the relationship between the multiplication of binomials and the multiplication of two-digit numbers. Now that's a lot to take in, so it's probably easier if we just do examples. So let's look at some basic algebra. Now, remember, whenever I give you something like this, we have the coefficient, the number in front, in this case 5. We have the variable, in this case x, and we have the exponent, in this case 2. Now this term is a monomial. Mono means one. A monomial has no addition or subtraction operations within it. Now this monomial represents one term. You've already seen a lot of monomials in the measurement unit. Remember these? Area for a square is s squared, the perimeter is 4s, for a cube, surface area is 6s squared, volume is s cubed. Circle, area is pi r squared, and so on. Now, each formula listed above is a monomial. As you can see, monomials can be expressed using numbers and letters or a concrete image or picture. So all of these are monomials, including the pictures. Now, a polynomial is made up of two or more monomials to terms separated by addition or subtraction signs. So here's a polynomial, 3x squared minus 8y. Now this polynomial has two terms. The two terms are 3x squared, or positive 3x squared, and negative 8y. Note that the plus or minus signs belongs to the coefficient. So it's minus 8. Okay? Now, we've seen examples of polynomials in the measuring unit. For example, the surface area of this cone can be found using the equation surface area pi r squared plus pi r s. And note this is a polynomial, two terms. We're adding them. Now, we have specific names for the different members of the polynomial family. Like 5x squared is a monomial, one term. 7x squared plus 3x is a binomial, two terms. 4x squared plus x minus 7 is a trinomial, three terms. And anything with four or more terms is just called a polynomial. So notice this, monomial, binomial, trinomial. I expect you to know that, 1, 2, 3. Now, let's look at another way to express these monomials and polynomials pictorially, using algebra tiles. Now, in the world of algebra tiles, we have 1s, x's, and x squared, or any other variable squared. Notice we're calling it x's, I call it y's, or z's, or a's, or b's, or whatever. Now, note that the square, or x squared tile, has the same side length as the height of the rectangle x. This is not a coincidence. This length is the same as this length, and this length is the same as this length. It's not a coincidence. Now, these tiles can be grouped together to form monomials and polynomials we already know and love. For example, 3, 5x, 2x squared plus x plus 3. This is x squared, another x squared, x, and 3. This is x, 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 1, 1, 1. Yes. Now I expect you to be able to count 2x squared plus x plus 3. Okay? Now, what about negative numbers and variables? Well, that's easy. We just use the same tiles, but make the tiles white to indicate negative numbers. Minus 3x, minus 1, minus 1, minus 1, minus 2x, minus x, x squared, minus 3x plus 2. This is plus x squared, minus x, minus x, minus x, plus 1, plus 1. Okay? Now, algebra tiles can help us understand how to add polynomials. So, when adding polynomials, we collect like terms, add the coefficients and terms that have the same variable. So, 3x plus 1 plus 2x plus 3. Now, if you're watching this at home, you probably don't have tiles, which sucks. If we're in school, we're playing with the tiles now. We put them all together. We have x, 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 x. So we have 5x, and 1, 1, 1, 1, 4. Okay? Now, negative numbers, remember, the positive they'll cancel all together. We put them together, and the positives and negatives cancel out. So here we have a plus x squared and a minus x squared. So they cancel out. We're down to x squared plus 2x minus 4. Okay? Now, if you're at home, you haven't got the tiles, but here I expect you to be able to figure this out. So let me see. This is going to be 2x squared actually, yes, so my apologies. Now minus 4x minus 1 minus 3x squared. Notice I'm making these hollow. Plus x minus 3 so what do we have here? Well, remember x squared and x squared cancels out. X squared and x squared cancels out. So what's left? Well, I'm going to move these out of the way. These cancel out. And what are we down? Oh, my apologies. I forgot. I missed that. Thank you. Yes. X and minus x cancel out. So I'm going to move this out of the way. No, you shazbot. Try that again. Now, much nicer if I was at school with the smartboard, but whatever. So what's left? Well, we have an x squared minus 2x minus 4, I believe. Okay. So there's my x squared minus 2x. Oh, come on, you can do it. There we go. Minus 4. Okay? Much nicer if you use tiles. But anyway. Now let's try the same thing down here. 4x squared. So that's 1, 2, 4. Now plus 5 would be 1, 2. Oh wait, sorry. So it's pointing out is a red. Sorry, my apologies. Getting old. Can't remember my colors anymore. 1, 2, 3, 4, 5. Now the minus x squared is hollow. Minus 5x, 1, 2, 3, 4, 5. Minus 5, 1, 2, 3, 4, 5. Now, point out here, x squared and minus x squared cancel out. I'm going to move those out of the way. Oh no, you shazbot. No, you don't. There we go. So those cancel out. My plus 5, my minus 5 cancel out. There we go. And what are we down to? Well, we're down to 3x squared minus 5x. Now, if you're manipulating tiles, that makes more sense. If you're sitting here watching it, it sort of kind of works. Now, I'm going to pause the recording here because it's getting kind of long, but I want you to get the idea of what's going on. So if you've got questions, shoot me an email or watch the video again.